Welcome to question 10 of the 2011 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So the figure shown represents a wireframe where ABCE is a convex quadrilateral. The point D is on a line segment EC, where AB is equal to ED, which equals 2, and BC equals A centimeters, where A is a positive constant. So all of that has been shown over here in the diagram, and it goes on to say that the angle BAE is equal to the angle CEA, which is equal to pi on 2, which really just says that there's right angles here and here. And we're going to let the angle CBD equal theta, which is this angle in here. And we know that that angle is somewhere between 0 and pi on 2, so it's an acute angle. For part A, we're asked to find the length BD, which is this length along here in purple, and the length CD, which is this length here, in terms of A, which is this length, which turns out to be the hypotenuse on a right-angled triangle, and theta, which was this angle in here that we discussed about before. So because this relates to a right-angled triangle, we know that we can use SOHCAHTOA to complete questions like this. So they relate angles and side lengths on a right-angled triangle. So we are asked about BD, which sits in the adjacent position. So that means that our cos of theta, so cos of our angle, is equal to the adjacent on the hypotenuse. So therefore, cos of theta is equal to, and the adjacent value is the length BD, divided by the hypotenuse, which is length A. So therefore, BD is equal to A cos of theta. So that is one of the answers we need for this question. So that means we can use sine of theta is equal to the opposite over the hypotenuse. So therefore we know that sine theta is equal to the ratio, and the opposite is the length of CD, and that is going to be divided by the hypotenuse length of A. So therefore we find that CD is equal to A sine of theta. And that is the second part that we needed for this question. So from the examiner's report we can see that 62% of students got full marks for that question, and 34% of students received 0 marks, with very few students getting 1 mark. The question required what the examiner thought was a straightforward application of trigonometry for a right-angled triangle. However, some students tried to use Pythagoras' theorem, reciprocal or inverse functions. Others mixed up variables as well as units in the question, and very few students only got one of the correct answers, meaning that people either got both or nothing for this question. Some students in this exam did not answer this question at all. For part B, we're asked to find the length L centimeters of the wire in the frame, which includes the length BD, which was in purple from before, and we want this expression in terms of A and theta. So therefore, the length L of the wireframe is going to equal, and using some colours to keep track of what we've done, this length here is equal to this length here, and they're both 2 centimeters. So 2 plus 2 is 4, and then we add on to that the length A, which is in green, and then we add on to that 2 lots of BD, because we've got one length here and a second length down the bottom, which is AE, but they're equal in length. So that is 2 lots of A cos of theta, and that's because we just found that BD was equivalent to A cos theta. And then the last thing we need to do is add on the orange length CD, which was found to be A sine of theta. So that is the length of the wireframe, which is in terms of A and theta. So for part B of this question, 58% of students got the mark for that. And the main thing that went wrong is that the second horizontal length of the wire, AE or BD, was missing from some responses, despite the particular mention in the instructions of the question. For part C, we're asked to first find dl d theta, and then hence show that dl d theta equals 0 when BD is equal to 2CD. So recalling that the length L was 4 plus a plus 2a cos of theta plus a sine of theta. So that was the expression for the length of the wireframe. We can then find that dl d theta is going to equal, and 4 doesn't have theta at all, so it's just a constant term that derives to 0. A, although it looks like it could be a variable, because it's not what we're differentiating with respect to, it's just some constant. So a derived with respect to theta is also 0. So the only two terms we've got to worry about is the 2a cos theta and the a sine theta terms. Now, as we said, a is just a constant, so that would be the same as if this was just overall 8 cos of theta. So 2a cos of theta is just going to derive 2. And cos goes to negative sine, so we get negative 2a sine of theta. And then we add on to that, a sine of theta will derive to a cos of theta. Now, from before, we knew that BD is equal to a cos of theta, and that's the purple line in this diagram, and that CD, which is in orange, was a sine of theta. So if we have that BD is equal to 2CD, we find that BD is equal to a cos of theta, but that must also equal to a sine of theta. So that's when we multiply CD by 2 over here, we'd get 2a sine of theta. So therefore, going back to the derivative, dl d theta, we find that that must equal minus 2a sine of theta. And now wherever we have a cos of theta, we're now going to replace it with 2a sine of theta. So we'll get plus 2a sine of theta. And we can see that minus 2a sine theta plus 2a sine of theta does in fact equal 0, which is what we were asked to show in this question. So from the examiner's report, we can see that 28% of students got this mark correct, with 58% of students getting 0 marks. So they weren't able to calculate the derivative, and then they weren't able to progress to showing what they needed to show. So the report goes on to say that most students who had L in terms of theta could differentiate that correctly. Some incorrect responses were a consequence of differentiating with respect to A rather than theta, attempting to differentiate with respect to both A and theta, or differentiating A sine of theta as A theta cos theta, which is also incorrect. And we see that the show that part of the question was rarely done well, with many students making a direct substitution, but making no mention of either BD or CD, which was necessary for logical, consistent working for this question. In this particular examination report, the assessor goes on to make a larger statement about show that questions. The report states that when answering a show that question, there are several approaches that students can take depending on the question. One approach is to start with the left side of the given equation and manipulate it to obtain the right side, and not assume that it is equal right at the start of the question. A variation of this is to start with the left side and simplify it as much as possible, and then work separately on the right side to see if the same point of simplification can be reached, thus showing that they are both the same result. And the next statement is really important, that the wording of the question is often a guide to the approach that can be used. Whatever the nature of the question, students must provide clear working so that it's obvious where decisions are made, so that the process used is clear. In particular, for question 10C, which we've just been discussing, students were required to show that the derivative was 0 when BD is equal to 2CD. This implies that having worked out the rule for the derivative, students would use the fact that BD equals 2CD in their derivative, and if all was well, they would get 0 as the answer. So that was the implied direction according to that statement. So the implication was not to start with the derivative equal to 0 and prove that BD equals 2CD. So it's really important to read the direction of the show that questions so that you know what information you're allowed to use and what information you're being asked to show. For part D, we're asked to find the maximum value of L if A is equal to 3 root 5. So if we need to calculate a maximum, we usually talk about the derivative being equal to 0. However, from a previous part of the question, the derivative equaled 0 when BD is equal to 2CD. So that was given to us from part C. So if we know that, we can redraw the right angled triangle, which had a green length of A, which is now 3 root 5, and we know that this length BD is equal to 2CD, where CD is this orange length here. So if we let this length be X, 2CD would become 2X down here. And now we could use Pythagoras' theorem to solve this equation. So we'd have x squared plus 2x in brackets squared must equal 3 root 5 squared. So therefore we find x squared plus 2x squared actually gives 5x squared is equal to, and 3 squared is 9 and square root of 5 squared is 5, so that is going to equal 45. So therefore x squared must equal 9, and we find that as x is greater than 0, it's a length, x must equal the square root of 9 is 3. So now we can annotate that onto our diagram. So the length of CD was simply x, so it's going to have a length of 3 now. The purple length BD is 2 lots of x, so that's 6, and this is also 6. And the A value is 3 root 5, and the blue values were still 2 and 2 respectively. So therefore the length that we're asked to calculate is going to equal, and the two blue lengths give 4, and then we add on to that the A value of 3 root 5, and then we add on to that 2 lots of BD, which is 2 lots of 6 is 12, and then we add on to that CD, which we just found to have a length of 3. So therefore the length of the wire structure when it's maximised is going to be 4 plus 12 is 16 plus 3 is 19 plus 3 root 5, and that is in centimetres as they were given as the units for this question. So that is the answer that we were required to find for part D of this question. From the examiner's report, we can see that only 5% of students managed to get that question correct, and that the examiner's comment reflects that very few students obtained the correct final answer. It was not a simple one-step problem, and most students did not make connection that the condition stated in question 10C provided enough information to use Pythagoras' theorem and calculate the lengths of all necessary sides to determine the maximum value of L. Another method involved trigonometry and right-angled triangles, and it is also detailed in the examiner's report.